Good morning. Today we will discuss about data cleaning. In the last session, we talked about data acquisition from different sources and in different formats. And at the end of that, we saw that we acquire data and we convert it into data frames. Now, these data frames that or the data that we have collected may not be clean enough. It may have a lot of noise and a lot of junk information which is required to be gotten rid of before sending it for learning a model or pre-processing stage, right? So data cleaning is the second step in the machine learning pipeline after data acquisition, and we'll discuss about it today. So I've created a sample data set where there are some columns and rows in the form of a CSV. So what we have is we have name, age, gender, salary, joining date and description. Now this name column has a lot of inconsistent formats. You see there's Alice Johnson has a lot of new line characters, Bob and Brown has a new line character, there are some trading white spaces and leading white spaces in this name column. There are some missing values in the age column, there is a missing value in the gender column, there is a spelling mistake in the gender column. Uh, there is inconsistent formatting, like all of them salary, all of them are numbers. Here we have a string with dollar sign and comma. The description field also has a missing value. So all of these together show a lot of the kind of data that we can get while acquiring data from different sources, right? So we'll see how we can take this data and clean it for further processing. So we'll start with acquiring the data. So in the previous sessions also I have seen we pass the CSV file to pandas read CSV and we get the data. Now when we see that data, as I showed in that CSV file also, there are a lot of slash and characters, there are spaces between first name and second name, some slash and characters, new line characters essentially these are called. So all these are there, we want to get rid of them. Missing values are replaced with NaN, so this NaN values also we need to get do something about them. There is this salary column which has this dollar symbol and a comma here. There is age also has a missing value, so we'll handle all of them. The first thing that we want to do is we want to remove the unnecessary spaces in the name column. Other columns are fine, but this name column has some uh, you can do this for essentially for any column in your data, but in this example we have the name column which has the spaces and slash and characters. So what we need to do is you have to first select this column and you say this column dot string str string version of that to strip. So when I do that, you'll see the leading and trailing white spaces will go away. So you'll see this John Doe, all these characters that were there are no longer there. But you see still there are some characters which are in between names, first name and second name. So it will only remove this column will only remove leading and trailing white spaces. It will not remove characters which are in between first name and second name or in between two strings, right? So for that we have to address inconsistent formatting, right? So what we do is that here we say that we replace all slash n with this thing, and I also replace all spaces with a single space. If there are multiple spaces, replace them with single space. So if I do this, and then what we are doing is we are converting the description and gender to lowercase. If I do all of this together, you see that all this has become very consistent with single space between first name and last name. There's a although these missing values are still there, we'll handle them. Right now what has happened is this name column is well formatted now. The description column is lowercase, the gender is also lowercase, right? So now that our name column is sorted, we'll go to another column which is salary, which has dollar symbol and comma. So similar to that, if you look at the salary type, it will show a string. Why this happens is because if you have any string entry in a column, all of them will become like strings, right? So that's why you see string here. So what we do is that you select the salary column, we replace the dollar with empty characters, we again replace the comma with empty characters, and after doing all this, for each entry we convert them into a float value because they are string initially, right? We saw here. So after this is done, uh, so after this is done, we get this salary column. You see the dollar symbol is removed, this comma is removed, and we have numbers here as a float value. Now if I just check the salary field, it will show as float 64, right? So because we have converted as type float. Now the next thing that we'll do is, you see there is a duplicate entry of John Doe in the first row and the last row, right? It's not recommended that you send duplicate information to a machine learning model for training, because that will make the model biased, right? So there's a drop duplicates function. If we call that, it will simply remove that row, and you will see that we have only 5 rows now, right? The last row is removed. Okay, now we have a much better data, cleaner data, but there are still missing values here, and there is a typo over here also. These two things we have to fix, right? Now to find which column have missing value, there is a function you can check data that is null and sum, and it will tell you which column has how many missing data. Like for example, here it says that name has no missing data, age has one missing data, your description has one missing data, and gender has one missing data. Right? Now one way of handling this missing data is you drop the row itself where there is a missing data. So if I do a drop NA, then it is removing the rows, which is row number 1 and row number 2, and it is keeping the remaining ones, right? But what happens is, if you have limited data, and data is very essential for machine learning model, you don't want to drop rows, right? So rather than dropping rows, can we do something else? So there is a fill NA function instead of drop NA, which replaces the NA value with certain value. Like for example, here you want to replace fill NA with 0. So what it will do is, it will replace all the missing values that was here, right? This was NaN, is replaced with 0, this one is replaced with 0, and this one is also replaced with 0. But the problem with such an approach is that you cannot have, I mean, of course you can do this at a column level as well, but the problem is you want to do a fill NA on some value or not on a constant value, because then that may not be valid, because age 0 doesn't make sense. Even if you put age 30, it doesn't make sense, right? So although this is one of the approach wherein you, if you know something, you put it here, but in case you don't know, what you do is, the second approach is you do a interpolation. You interpolate the data to find out. So what is there is, draw the line between the first and the row before, which has a NaN, and after NaN, and tries to find a point in between them. Like for example, 25 and 32, it is trying to produce a value 28.5, and it is replacing that NaN value with 28.5, right? So if the row was between 2 and 3, it would have got a value between 32 and 45, like a 38 or 39, right? But you see in the gender column, 0 doesn't make sense, description doesn't make sense. So this has to be handled at a column level, not on the entire data frame, right? So what we do is, let's say, again, we want to, let's say, do it with a mean value. That is another approach, which is mostly used also. But the problem here is that if when you do a mean, it will work on numerical columns like age and all. But for this kind of columns with gender and description, which are string kind of columns, this mean column doesn't work. That's why there is an error, right? So for this, what you need to do is, you have to apply this fill NA function to specific columns. Like as I told, like for this gender, I do a fill NA, and I will do a mode of this column, whatever is the mode, and I will replace that value with this fill NA, right? So the mode of this I am creating, and I am replacing this with that. What mode means is that which entry occurred most. So if you look at gender column, female have appeared twice, male appeared once, and female appeared once. So most occurring is female, so this NaN will be replaced with female. Similarly, if we look at description, all of them are different, so all of them will have frequency 1, so it will take the first one, and this NaN will be replaced with this data scientist. And for this case, for the numerical column, it will find the mean, and it will replace this entry with a mean value of the remaining ones. So that is what is shown here. Like this is replaced with 32.5, which is the mean of 25, 32, 45, and 28. This is replaced with female, because female was the most occurring, and this is replaced with data scientist with ... which is the first row, because all of them had the same frequency. Now this data is very clean. Only one issue that is remaining is this female, right? For that, if you want to handle this, there's a library called Fuzzy Wuzzy. So what we need to do is that we know that this gender column can take values only male and female, right? Now, if you compare this female to the word female, it will be closer compared to male. So there is the first ratio function wherein you can compare two words. Now, if I compare female to female, it will give you a score of 83. Whereas if I compare female to male, it will give you a score of 60, right? And we take advantage of this and to decide whether something is a female or a male, right? So we say list of possible genders, and we apply, for each of these entries we apply correct typos, right? If there are any typos in each of them, it will do. So what it will do is this function will try to find the max score between male and female, and based on that it will return the best match, right? And this best match will be used to set this data. Now if I run this, you'll see that this female is replaced with female. Right? So these are some of the data cleaning techniques. There are other data cleaning techniques as well, which we will see when we cover NLP and NLP especially, where we deal with text handling. We haven't done any cleaning on this description part. We'll do that later when we handle natural language text. But for the time being, I think we'll mostly deal with categorical and this kind of values. So for this, this much should be enough for now. And this closes the data cleaning part. In the next session, we'll cover exploratory data analysis, and subsequently we'll cover uh, data pre-processing. Thank you for attending this.